Assalamu alaikum, beautiful class. So for chapter 5, like we discussed, we'll be doing a flipped classroom setting. We'll be watching these lectures at home, and then we will be doing projects and homework in the classroom. And hopefully, inshallah, we'll see if it works out better. We'll take a vote at the end of this chapter and see if you want to continue this method or not. So first thing I would do is I want to apologize that this will not be leaving because unfortunately I'm not connected to Starboard. So this error message that Starboard is not connected will be with us the entire time, but that's okay. We can work through that. You'll be seeing that the last 2 days, and by the time you recorded this, by the time I recorded this, or by the time you listen to this, actually, you would have done 2 days of a project with the triangle, and you'll notice that you were not given much information on those triangles, and you had to research all the information yourself. And that's part of the flipped classroom method, where you do have to do a little work, researching by yourself. And they say that itself is going to help you remember the things more when I get around to it. So inshallah, hopefully this works out. And if it doesn't work out for you, just bear with me for chapter 5. We can go back, take a vote on who likes this and who doesn't like this. So, however, let's get started with this. And then we always we start out with the definition. So in this case, the definition is mid-segment. We're going to be finding out the mid-segment of a triangle. Is mid-segment of a triangle is a segment that connects the midpoint of two sides of the triangle. Every triangle has three mid-segments. So what we're going to do is we're going to take this line right here, line segment AB, and we're going to find the exact middle of this line. It's right here. M is what we figured out. So M is exactly between line AB. So what that means is, if you notice that this area of AM and MB are going to be equal segments. They're going to be equal. And the same thing goes with line segment BC. We're going to find the midpoint, and it's going to be P. And for line segment AC, the midpoint is going to be N. Now, what that means is that the line that they're dividing, for instance, P is dividing line segment BC. So this area here and this area here are going to be equal to each other. If you notice, though, however, we use this, and three different types of equal notations because we do not know just by finding the mid segments if these lines are all equal to each other or not. Each side of this triangle could be its own side. So after we figured out these three midpoints, what we did was we took midpoint M and we connected to midpoint P. And we took midpoint P and connected to midpoint N, and midpoint M and connected to midpoint N. We made a smaller triangle within our larger triangle. So how do we use this information? Well, that's what we're going to be doing in the next slide. You see that midpoint of BA is going to be D. And so what we do is we mark this area as a midpoint, and then we're going to be finding the midpoint of line segment BC, which is going to be E. And we mark that as a midpoint. So because it's a midpoint, you notice that both sides are going to be equal to each other on the other. So BE is going to be equal to EC, or we use the word congruent, and BD is going to be congruent to BDA. So what we're going to do is we're going to take this line and we're going to connect it together right here. So this is going to be using the mid-segment theorem. Make it nice. So there's two things we know from this information. We already went over this in class, so you might remember this. The first thing is, if you notice right over here and right over here, we got these two sides, and then you know that means they're parallel. So this line right here, and let me make this very long. This line and this line wasn't exactly equal as I would like it. However, because they're parallel, according to the mid-segment theorem, they were never, ever going to touch each other. So that's one information we know. The second information we know is that line segment DE, which I'll highlight in pink, is exactly half of line segment AC, which I'm going to highlight in green. So that means if we were given the information for either one of those, we can find out the information for the other one. So let me erase this information right here, and let's do a few practice. So if I knew line segment AC is 10, that means right away I will know line segment DE is 5. And the exact opposite is true also. If I know line segment DE is 6, I can do the math and find out that line segment AC is actually 12. So I hope you're getting the hang of this. Let's do a harder one. Let's do AC is 19. And so line segment DE in this case is going to be half of that. And if my math is correct, it's going to be 9.5. And one more time, the exact opposite is true. If I say this is 4.5, then I know that this area is going to be 9 for line segment AC. So that's how you can use the mid-segment theorem. So let's use this in practice. So this is an A-frame on a roof, and you notice if you've ever looked inside a roof of a house, this is exactly how they make it. So with a diagram, with a board problem in geometry in any math class, you should always draw everything out. So let's see what information they're giving us. They're telling us that in the diagram UV and VW, line segment VW, are mid segments of triangle. Let's see which triangle we're using. Let's mark this in green. RST. So this triangle here, which I highlighted, was just a little off. Let me see if I can get it done better. It doesn't seem like it'll be much better. But these are mid segments right here and right here. So we're going to use that information to solve this. So what that means, first of all, let's use the information we know that because V is the midpoint, that you know that S and this area is going to be congruent to each other. And because W is the midpoint, you know that the area between RW and WT are going to be congruent to each other. And since U is the midpoint, you already know that line segment RU is going to be congruent to line segment UR. So let's use this information and figure out what they're asking us. They're asking us right now for UV. What is the length of UV? Well, this is a mid segment, like they told us. So we have to use another information. Now, because this is a mid segment of this area, we can use this information to find out what UV is. Now, remember from the mid segment theorem that whatever this is, half of that is going to be line segment UV. So it makes our life a lot easier. So we're going to find out the line segment UV is actually just 90 divided by 2. So we realize from that the UV, line segment UV is going to be 45. So that's pretty easy. The second question they're asking us is what RS is. So this area right here. What is RS? So for that, we can use the mid-segment theorem again, and you see VW is a mid-segment for RS. So because VW is 57, we can multiply that by 2, and we can get line segment RS, which is going to equal, my math is correct, 114. And if you look right over here, I have the solutions right here. We are correct in what we found out. So let's use this information again. Remember, this is the A-frame of the house. You'll notice that in the north, they have a more vertical shape for A-frames because there's a lot of snow that goes on it. So you got to make sure it's strong enough to handle it. So once again, we're going to start out with information that we're given. We have to draw that out. So we think that DG and DH are mid segments of line or triangle ABF. Right, so let me try that one more time, see if we can get this corrected. ABF. That's better. So the information they're going to ask us is to find line DG. So we're going to find out what this mid-segment length is. So when we're working with a mid-segment, they're probably going to give us this length right here. Right over here, they can give us this length probably. And they did actually. Right down here, they gave it to us. They said it's actually 12 feet. Now, if you know the mid-segment theorem, they're saying this is going to be 12 feet. So this area of the mid-segment is going to be half of that. So we know from that information that, let's write this out, that DG, we can say line segment DG is equal to half of AF, line segment AF, which is going to be 6. The next information they're asking us for BF. So BF is right over here. Once again, using the mid-segment theorem, we know that they gave us this area right here. So we're going to use that to find out what BF is. So this area is 10. So according to mid-segment theorem, this will be twice as long. So this is going to be 10 times 2, which is equal to 20. So area BF is equal to 20. So then we work with coordinate proofs, and this is another definition. A coordinate proof involves placing geometric figures in a coordinate plane. When you use variables to represent the coordinates of a figure in a coordinate proof, the results are true for all figures of that type. So what does this mean? So let me start a new page up, and let's make our lines. This is my y coordinate, this is my x coordinate, and it didn't fix it up and make it straight for me. Let's try it again. My y coordinate, and this is my x coordinate. Perfect. So what we're going to do is let's make a rectangle first. And we're going to make a rectangle in blue right here. And it fixes it up well. What we're going to do for this thing is we're going to put the point right here at 0, 0. So we're going to mark the 0, 0. So we have to figure out what point this is. So this point is going to be however far it goes up here. Let's give this the variable k. That's gonna be your x-axis. So there'll be 1, 2, 3, 4, 5, 6, 7, 8, whatever this number is. We're gonna mark this k. The y variable, remember, hasn't gone up yet. It's still on the y axis, the x-axis. So we're gonna call this 0.